All right, so summarizing what you guys just talked about here. Right, so we want to remember polar. So we have a radius and an angle, right? And I want to talk about dA. And I want to think about dA in terms of dr and d theta, right? So I'm going to say, okay, this little box here, that thing's delta area, right? And I know the change in the length out there is d theta. And then I want to know, how long is this other side? So I need to remember something about the length of a sector or something.
Arc length.
Yeah, arc length. And that's the radius times the angle, right? What's the angle on this one?
Delta theta.
Yeah, the angle on this one's delta theta. So if I thought about that little guy, right, as a box, right, so if I just kind of squared it off. Oh, whoops, I didn't even square it off. So if I kind of square it off, right, I'm going to end up being off. I know that. This is only approximately, right? But that box is more or less delta r on the one side and on the other r delta theta. And so change in area, right, is approximately r change in theta change in r. And I hope that it's clear that it should depend on the radius at least, right? Because if I went in here and did that same change in radius, right, that might be this size. You guys see that one? Versus that size. Those are pretty clearly different. And it's pretty obvious that it doesn't depend on the angle, right? You guys see that? Like, I drew X and Y axes on here, but who cares, right? I don't need the X and Y axes there to know anything about this picture. You guys see that? Does that help, Jacob?
Yeah.
Okay, so what we found is that d area is r dr d theta. Oops, that's not a remote.